Today's aim is that we are going to be able to solve equations for y to get slope intercept form. So as we talked about yesterday, solving equations or graphing equations that are not in slope-intercept form is much more difficult. In your do now, you had two different types of equations, one in slope-intercept form, one that was in standard form. Where they raised hand, which one was clearly more time-consuming? Jalil. The one where y is by itself is more time-consuming. It's more difficult. It takes longer. Edwin? Yeah, the standard form one was definitely a lot more difficult. It took a lot more time to get that problem done. And so one thing that what we're doing today is something that I don't normally teach until after CST. Okay, it's not even a 7th grade standard. It's definitely an algebra standard. The reason why I'm teaching it now is because I feel like, number one, that you guys are ready for it. And I feel like, number two, I want to give you another way to graph standard form equations, another way to deal with standard form equations that's a little bit simpler, at least as far as I'm concerned. That's less time consuming. That way you have a choice, just like you do with slope-intercept form. Slope-intercept form you can plug and chug, or you can use point and slope. So today we're going to be learning a way to take our equations that are not in slope-intercept form and change them so they are in slope-intercept form. Michaela. So remember that slope-intercept form equations are solved for y, whereas standard form equations are not. And so we can't have a slope and intercept given to us in standard form, so we actually have to plug and chug. However, today we're going to be looking at being able to change it so they are. I've given you your 2 key points already. It says solving for a variable is just like solving an equation for the unknown. Okay? So just like any other equation we've solved all year, we're going to take the same steps. The only difference is we're going to do the inverse operations while simplifying the expressions on the other side. So on the right-hand side, we're not going to come out. We're not going to be able to come out and just get a number over here because there's an x here that we don't know. But we are going to be able to simplify an expression after doing our inverse operation. So what I normally suggest is sometimes I usually take a Post-it note and I will actually completely cover up the right-hand side of the equation, and I will look at just the left-hand side of the equation. That way there's no confusion about what needs to go on here. So looking at this equation, if this was our equation, what inverse operation would we have to do to get the y alone? Jalil. The additive inverse, which is adding what? Plus negative 3. So remember, if we do something to one side of the equation, we have to do it to the other. So we're going to flip over to the other side. I'm actually going to leave change switch this as I do. And I had to add another negative 3 to the other side. As I add that negative 3 to the other side, I have 3 plus negative 3 on the left-hand side of the equation. That adds up to 0, so it cancels out, leaving me with y. Now, x plus negative 3 plus negative 3. Can I combine all 3 of those things? Yes. I can combine all 3 of them? No, we cannot. We can combine what, though? Marta? The 2 negative 3's, and that's going to give us I think Desiree just said negative 6. So remember, the entire point of this was what? Why did we want to solve this for y? Jordan? Yeah, so it's in slope-intercept form. So remember, that's the entire point here. So what we're also going to do today is we're going to make sure that we're focused in on, once we get our equation in slope-intercept form, reminding ourselves how we're using that and why we're using that. So for this particular equation, what is the slope of the equation? This one's a tricky one for slope. Noemi? That is not our slope. Remember, the slope is always the coefficient of the x. Michaela? Yeah, our slope is 1. If we wanted to write that in rise over run form, we'd write it as 1 over 1. What is our y-intercept? Give it to me in coordinate pair form. What is our y-intercept? Quintana? 0, negative 6. Remember that plus b, whatever's added over there is our y-intercept. And that's it. We took an equation that wasn't in slope-intercept form, and we changed it so it was in slope-intercept form. Now we can graph this using the y-intercept and the slope, as opposed to having to plug and chug. Yes, sir? So we had no coefficient on our x. And remember, if there's no coefficient, that's just a coefficient of 1. So we just put the 1 on there so we could see it. Yes? If there is a coefficient, then that's our slope. Okay. Moving down to the next one. This next one's going to be a little bit different. One of the things that we didn't do in the first one that we actually do need to do every time is make sure that we're doing all of our leaf change switches first. So I'm going to start off this problem by going ahead and doing this leaf change switch. Next thing, focusing only on the left-hand side of the equation. If I want to solve for y, what is it that I need to do to get y alone? Isabel? So I divide by 3. Now this is where we have to be really careful. If we divide one side of the equation by 3, we have to divide the other side of the equation by 3. But how many parts are there to this side of the equation? 2. There are 2 terms here on this side of the equation. We have to divide both terms by 3. So it's actually using the distributive property. So I'm going to rewrite this as y equals 9x divided by 3 plus negative 27 divided by 3. Nine x divided by 3 is what? 3x. Don't forget the x. A lot of people forget the x, and then they try and combine things, and then we're totally wrong. Negative 27 divided by 3 is negative 9. Now again, remember, the entire point of doing this was to get into slope-intercept form. Kip yes or kip no. Are we in slope-intercept form now? Yes. Yes. So what is our slope of this equation? Frida? 3 over 1. So she has taken our slope over here, our coefficient of our x. She said it was 3. She wants it in rise over run form, so she put it in fraction form over 1. And our y-intercept is what? Marta? 0, negative 9. And that's it. So we've again taken another equation that was not in slope-intercept form, and we've changed it so we can use point and slope. It's a little bit more work to get there, but in my mind, this is a lot easier. I'd rather do this equation solving once than have to do equation solving 3 times to get the 3 points for plug and chug. This one's going to be a little bit more difficult because there's more going on here. First thing I need to do is what? Before we do anything else, Patrick, leave chain switch. Next thing I'm going to tell you to do is just focus in on the left-hand side of the equation. Again, for some of you, I may at some point come around today and give you a post-it note so you can just ignore the right-hand side of the equation while you're trying to figure out what to do. What inverse operation is it that I need to do first to help get the y alone? Mauricio?
You have to divide 3, not add 1 and 2 both.
Can't do both at the same time. Which one's first? Adding 2. Remember, we always do adding inverses first. So if I add that to one side, I must absolutely do the same thing to the other. So I've added 2 to both sides. Negative 2 plus 2 cancels out, leaving me with 3y. 12x plus 4 plus 2. That is 12x plus 6. Kip yes or Kip no? Are we in slope-intercept form?
No.
No, our y is still not completely alone. We've got one more step we need to do in order to solve for that y, which is what, Desiree?
Divide by 3.
Divide by 3. Now, if I divide one side by 3, I have to divide both sides by 3. Keeping in mind there are 2 terms here, so we have to divide the entire side, which means dividing both terms by 3. That gives us our slope is 4. In fraction form, that's 4 over 1. And our y-intercept, 0, 2. Okay, that one was a little bit trickier. The next one is realistically just as tricky, but we can do the same thing. Now, when we're looking at this one, there are 2 things that have happened to the y term here. What 2 things have happened to our y term? What 2 operations have happened on the y side? Jalil. We have to solve for y because 2 things have happened here. Remember, we are focusing on y, and that's the point that Jalil's trying to make here, is we're focused on the y. Yes, there's an x over here, but we're not solving for that x. We're not worried about what's happened to that x term. We're worried about what has happened to that y term. Michaela, what has happened to that y term? Jordan, what has happened to that y term? Multiplied or added, because one of those is right and one of those is wrong. I'm looking at my y term. Has anything been multiplied to my y term? No. What has happened to my y term? Added what? And added what? 4. So we have 2 things added. So that's 2 inverse operations we're going to have to do here. What's the inverse operation of adding the, let's start with the 3x. What's the inverse operation of having added the 3x? Frida. Sorry. It's addition. What's the inverse operation of addition? Add the opposite. So we added 3x to the y term. So we need to add negative 3x. If I do it to one side, I have to do it to the other. So 3x plus negative 3x is what? 0. Cancels out. That leaves us with y plus 4 is equal to negative 12 plus negative 3x. I'm going to do one thing here. Just because I know we're trying to get into slope-intercept form, when I rewrite this step, I'm going to commute my terms to get that x term first. So I can't combine those, but I'm going to commute them so I get that correct term first. I heard Desiree saying, well, now I'm looking over here, y still isn't alone. I still have y plus 4. Well, that's a simple inverse operation. This is a problem that we've done one exactly like it already today. Michaela, what do I need to do to get the y alone? Add a negative 4 to both sides. Negative 3x can be combined, so it's going to stay. Negative 12 plus negative 4 is negative 16. So our slope of this equation is what? It's not 3 over 1, it is negative 3 over 1. And our y-intercept -16. Okay. And look at the next one. The next one's got another really tricky thing in it. First things first, we're going to look over here. It says 1/2 y plus 4. What is the first inverse operation we need to do to solve this equation? Michael?
Add negative 4.
Add a negative 4 to both sides. 1/2 y plus 4 plus negative 4 is equal to x plus 2 plus negative 4. What remains on the left-hand side? Layla, what remains on the left-hand side? 1/2 y. On the right-hand side, we have x plus x plus negative 2. Again, we still don't have our y alone yet, so we need to think about the inverse operation that's going to get our y alone now. Francel? Multiplying by the reciprocal, which is 2 over 1. 2 over 1 is the same as what whole number, Mauricio? 2. Now, again, very careful. Excuse me. Being very careful here. If I have two terms, I have to multiply the entire side by 2 over 1. I'm putting parentheses around it to make sure that I'm saying this as a group has to be multiplied by 2 over 1. Which means what property do we need to use here? Distributive. So I'm going to distribute this multiplication of 2 to both parts. X times 2 is 2x, plus negative 2 times 2 is, our slope is what? 2 over 1. Our y-intercept? 0, negative 4. One last one. Now, looking at this last one, this is what dreaded form of the equation that we've been working with a lot recently, having to use plug and chug for. What form of linear equation is this, Frida? This is standard form. This is that equation that we saw in the second, not the exact equation, but this is the form of the equation that we did all that plugging and chugging for on our second do now problem. So this is where you need to decide, how do I want to solve this problem? Do I want to solve it by solving for y, or do I want to plug and chug? It's your decision. What's the first thing that I would need to do to solve this equation, though? Standard setup for everything. Marta? Yep, change and switch. Now I'm going to look over here at just the left-hand side, where that y is. And I'm going to see two things have happened to the y term. It has been multiplied by 2, and it has had negative 4x added to it. What inverse operation do I need to do to help get the y alone? Again, zero focus on the x here.
Positive 4x on the other side.
Yep, so we need to add positive 4x to both sides. Negative 4x plus positive 4x is 0, leaving us with 2y is equal to, I'm going to commute my terms really quickly. 4x plus 8. The reason I commuted my terms was because I want this to be in slope-intercept form, so I want that y equals mx plus b. I'm not quite in slope-intercept form yet because my y is not quite alone. So Patricia, what do I need to do to get that y alone? Divide both sides by 2. Again, being reminded, when we divide this side by 2, there are two terms. Both have to be divided by 2. It's like the distributive property. In fact, it is the distributive property. So that's 4x divided by 2 plus 8 divided by 2 gives me y equals 2x plus 4. What's my slope? Slope is 2. In rise and run form, that's 2 over 1. My y-intercept?
0, 4.
0, 4. That's a 0, I promise. All right?